Imagine a fully staffed virtual workforce, thousands of specialized AI agents standing by to negotiate contracts, analyze data, and execute workflows at a moment's notice. But building that workforce reveals a massive friction point. If you want an agent to read a Google Doc or update Salesforce, you have to manually write custom REST wrappers. You must configure specific API keys and build custom JSON parsers to get two systems talking. Without open standards, connecting a diverse ecosystem of independent agents to your internal tools quickly becomes a chaotic, unscalable engineering project. Relying on bespoke integrations creates a mountain of technical debt. It traps developers into playing the role of mechanics, constantly wiring fragile APIs instead of building new value. The severity of this problem becomes obvious when we look at the math behind testing different language models against external tools. This formula shows the actual integration complexity we face. It's defined as O of n times m. To put that into practice, if you want to test 5 different AI models and connect them to 10 tools like Jira or BigQuery, you are forced to write and maintain 50 separate custom software bridges. This multiplicative workload guarantees that a growing AI ecosystem will collapse under its own weight unless we adopt a universal socket. The architectural fix requires us to cleanly separate an agent's internal intelligence from its external network connections. First, we define agent skills. This is the internal know-how. They are simple markdown files and playbooks that teach an agent how to sequence tasks, handle edge cases, and think about the work. Then, we introduce the Model Contact Protocol, or MCP. If skills are the know-how, MCP provides the reach. It acts as a universal USB-C port, instantly connecting the agent's logic to external databases, file systems, and web APIs. By standardizing how tools are defined, MCP routes all data transports through a single plug-and-play architecture. This updated equation shows the shift in scaling. The integration burden drops from a multiplicative problem down to a clean linear scale, O of n plus m. MCP bypasses the prototyping bottleneck. Developers can swap out models or add new databases instantly with zero custom integration code. Connecting tools is a start, but applications require highly specialized agents built by entirely different organizations. To prevent the ecosystem from fragmenting into isolated silos, we rely on the agent-to-agent or A2A protocol. A2A abstracts away the underlying code. It allows a central orchestrator agent written in Python to securely discover and delegate work to a bespoke enterprise agent living on a separate network. The A2A protocol acts as the HTTP of the virtual workforce, standardizing discovery and communication across vendor boundaries. These protocols become vital when agents start taking actions with financial stakes. Consider a scenario where you deploy an AI assistant to autonomously order late-night food from a local restaurant. When humans need to review options, the Agent-to-UI protocol, or A2UI, converts raw JSON data from the restaurant into safe, interactive visual components on your screen. This diagram illustrates the Universal Commerce Protocol, or UCP. It negotiates with external merchants, navigates menus, and compiles the final order. On the right, the Agent Payments Protocol, or AP2, acts as a strict financial guardrail, enforcing human-signed mandates so the agent cannot overspend. Together, UCP and AP2 bridge the gap between digital reasoning and trusted, real-world economic execution. This flowchart maps out the complete ecosystem. Tools, human interfaces, and commerce gateways all plug securely into the same core agent logic hub. We are moving away from isolated, single-agent monoliths toward a distributed microservice network of specialized AI. Embracing these standard transports is the only way to build reliable, plug-and-play AI platforms instead of fragile custom machines. As the ecosystem accelerates, developers who continue to rely on legacy standard-of-one APIs will drown in integration debt. Adopting open standards provides the critical underlying infrastructure required to securely build and scale a fully operational digital workforce. These protocols elevate the developer's role. You stop being a mechanic wiring fragile APIs and become the architect of a global autonomous economy.